Machine learning for web developers. Before I get started, quick introduction. My name is Faiz Nodegwa. I'm a CTO at Philantro Lab. I'm also a Google developer expert. So I work at the intersection of web and machine learning. So I think I'm in the right position to talk about this to everyone because I'm interested in web development. I'm interested in front end, back end. I'm also interested in machine learning, data science as a whole. So I'm kind of at the point where I want to fuse these two ecosystems together. Okay, so next slide. We have what is artificial intelligence, classical approach to programming, what machine learning is. Then we'll talk a little bit about deep learning. Then we'll talk about some code and no-code tools for ML, and then some demos, then there's a conclusion. So quickly, I'll just go to what artificial intelligence is. Okay, now it's made up of two words, artificial and intelligence. Okay, so if we talk about intelligence first, it can be described as the ability to infer, meaning to get information, basically get data. So for instance, I'm looking at you at the moment, I'm getting raw images from you all. Okay, now I can take that image of you, I can process it and turn that into an information. How is that an information? I know that you are a guy. Hope you're a guy. Because the raw images has been fed to my eyes as raw data, and then with the info, I've been able to process that information with my experience, being able to label, these are guys, these are ladies, these are women, and so on and so forth. So I get that information, I process it, I get that raw data, I process it as information, and I'm able to retain it, then I'm able to use it to adapt or use it in the context of an environment. So I can call myself intelligent. You can call yourself intelligent, okay? If I memorize the idea of a person, I can't call myself intelligent. So memorization is not intelligence, okay? So we're going to talk about that later because of classical programming approaches. So, but for now, this is what we define intelligence to be: ability to abstract, logic, understanding, learning, creativity, planning, problem solving, and so on and so forth. Please, next slide. So this is intelligence flow, like I was saying just now. You get raw data, take that raw data, you infer information from that data, you retain it as knowledge, this is important, and then you apply that knowledge to a new environment. Now, once you apply to that environment, the learning process is continuous. So you continuously get data and improve your knowledge, okay? So what is the artificial there? So artificial just means that intelligence demonstrated by computers or machines is called the artificial intelligence. So the ones that I generate, the ones that I do is called natural intelligence. That's humans, animals, and the rest. But we're in the field of computer science, the artificial intelligence is intelligence that is done by machine or machines or computers exhibit. I know you might be asking, how can machines or how can computers exhibit the kind of intelligence that human beings exhibit? How can we call a computer intelligent? If I've said that a computer must be able to take data, retain the information, and use it in new environments to be able to adapt. Because if I memorize the idea of a person, if I see a shape that looks like a person, I might mistake that into be a person as well, and that's not true. Okay, so I should be able to adapt. So can computers do that? We'll find out. So the field of artificial intelligence is a very large field. There are lots of things under it. We'll not get into them, but there's one important part of it called machine learning, which we'll talk about. So basically, next slide, please. So, okay, here is just talking about AI, and this is Sundar Pichai, the CEO of Google. He's just talking about how AI is very important to the feed, to everything they do at Google. Basically, almost every product at Google uses one form of AI or the other. So if you notice, search is not smarter at Google. Natural language processing like speech translation, transcribing, they are now very, very good at Google. It's because in the recent years, Google has been using more AI in their products. So basically, across all their products, YouTube, recommendation is better on YouTube. So YouTube, search, and everything. Gmail gives you autocomplete. That's AI in work. So you can see, they use it. This is Andrew Ng, one of the founding fathers of deep learning. And it says that we are making this analogy that AI is like a new electricity. So it is so important that it cuts across all fields. So whether you are in data science, whether you're in software dev, anything you do, AI can be used there to make a difference. So next slide. This is CEO of Microsoft. Same thing. They're infusing AI into all their products. Next slide. So now we'll talk about the classical approach to programming. Okay, so I talked about intelligence, and I was like, how can machines be called intelligent? We've defined intelligence. Now, how can machines, how can your computers, how can your software, how can your application be intelligent? Now, there's this classical way of programming that we all do, even till now, whereby we get a problem, then you as the developer or the architect or anything you call yourself, you observe the problem, and then you kind of like come up with a bunch of rules, come up with an algorithm, something to solve the problem, right? So you lay down those steps, and you basically do what? You code those rules, and then it gives you a solution. Now it's fantastic. Your accounting software, your most websites, basically you just go there, put a bunch of inputs, it gives you an output. Now that is static, meaning what you give to it, it will always get the right result out. So meaning developers have been able to identify that problem and create the rules. So as long as the input does not change, you get the same output, right? So if you change the input, the program might crash, or the program might tell you that's incorrect input. It cannot adapt. Why? Because the rules have been coded inside. So this is like the classical way of programming. Next slide, please. Now, the classical way is nice, fantastic. We still do it all the time. We still use it in our day-to-day developer work or in our day-to-day programs, but it fails in some context or in some kind of like problem. So problems like image classification, detection, segmentation, speech and audio tags, video tags, natural language processing and big data, it fails. I'm going to give you an example. So if I ask the people here that, what is this? If I give you an image of this and I ask you, what is this? What will you say? Can anybody just? Sorry? Plastic bottle. Okay, so how did you know it was a plastic bottle from this image? Sorry? The plastic bottle is at the middle. So I'm asking you, as a human, you saw this and you were like, this is a plastic bottle. But how did you know? How did you recognize that it was a plastic bottle? From experience and the shape, right? Awesome. Okay, now, if I place this plastic bottle at this side of the screen, is this still a plastic bottle? It's still a plastic bottle. So irrespective of the position I put it, what if I cover just the top? Is this still a plastic bottle? Yes, you still recognize that it's a plastic bottle. Now, the problem is that if, as a programmer, you saw this problem, image of a plastic bottle, write a program to tell me if this is a plastic bottle or not, how will you write that program? What kind of steps will you take? Can anybody try? Just quickly. Yeah.
First thing to do is to take photos of the bottle, and then you, like say, model it.
Okay, so you write a program to detect the features of the plastic bottle in an image, depending on the shape, the color, and everything. Okay. Now, you write that program fine, right? And for instance, the image you wrote that program for, the plastic bottle was in the middle. So you wrote a program to go to a specific part of that image and cut out that shape, check the transparency, check different things. Now, what happens if I change the position of this image? Will your program be able to adapt to? It fails, right? What if I have just half image? Will your program be able to adapt? No, because your program is looking for the image at the middle of the screen. So classical approach to problems like image classification, being able to identify image fails. It's not maintainable. If it even works, it's not maintainable, and it mostly fails because these problems are difficult. They are mostly cognitive problems. Things that we do easily are very difficult for computers to do. Things that are difficult for us to do, mundane tasks, are very easy for computers to do. So we just look and see. We just hear and we can interpret. It's easy to you, but for you to program a computer to do that is very difficult. So classical approach fails. That's why your normal approach of software engineering will not work. That's where machine learning comes in. So please, next slide. So machine learning comes to the rescue. So what is machine learning? Now we've talked about intelligence, we've seen the classical approach, and I told you that machine learning can help us solve that problem. So what is machine learning? So it's an automated approach where a machine analyzes data for certain patterns and apply these patterns to new tasks. So it's almost similar to the way we learn, whereby as a child, you see your parents always call it this thing, plastic bottle. Every time you ask, Mom, what's this? Say plastic bottle. Tomorrow you might call this an onion. Mom will say, no, it's not an onion. It's a plastic bottle. So you keep hearing that this is a plastic bottle, this is a plastic bottle. So you identify, so you tag a label to the idea of this object. Meaning you saw continuous example, and somebody was telling you that anytime you see an image like this, it is a plastic bottle. So that's basically the way machine learning works. So instead of getting a problem, trying to craft out rules, then code, then get the solution, machine learning, next slide. Machine learning just give it examples. So just give it images of plastic bottles, lots of images. So the machine learning algorithm or the model will take those examples, and by itself, it will get out the rules from it on its own. So that next time when you give it a new image, based on this experience or based on these examples it has seen before, it can tell you that this is a plastic bottle or this is not a plastic bottle. So it's like modeling the way humans learn. So from examples, we get the rules, not the other way around. Not from problem to rules, but like from the solution, from a bunch of examples, a bunch of answers, it automatically gets the rules for us. Okay, so that's basically machine learning. Now, there are lots of different algorithms, lots of things that you can use. You can just plug, give it your examples, pass it to a model. It will learn. Then you can use that model in your applications, maybe in your web app, in your backend app, anything. So there are lots of algorithms, lots of ways you can train these models. Basically, that is the whole of machine learning. Different ways to train models, different ways to train things. Anytime you hear somebody saying, I'm training my model, it means they are passing a bunch of examples that they've collected and labeled to that model for it to learn. Okay? So next slide. So machine learning is a very broad field, and there are different types. I'm not going to go into this, but there's like unsupervised learning, supervised learning, reinforcement, and they have these different fields depending on what you want to do. For instance, you can see image classification here, something that we just did, classifying a plastic bottle. So that falls under supervised learning. So there are different ways or different types of machine learning. So please, next slide. I'm going to just be very fast. So I don't know if anybody has heard of deep learning. Deep learning. Do you do ML? You all do ML. How many people do ML here? Oh, just, okay. Okay, but you've heard of deep learning. Oh, for non-ML people, you've heard of deep learning. Yes, it's very popular. Deep learning, deep learning, deep learning. So what is deep learning? And what's the relationship between deep learning and machine learning? Well, it's simple. Deep learning is a type of machine learning. But it's a type, it's like, I told you that machine learning have different algorithms or different ways that you can train models. So deep learning is like a type, another subfield under machine learning. It's a different way of training models. And it's very effective at some particular tasks. So for machine learning, you can apply machine learning to structured data. For instance, I want to predict, like most fintech today, like most lending app, if you want to borrow money, they can predict your credit worthiness. How worthy, if I give you a credit or a loan today, will you pay me back? They can predict a score based on your demographic, based on your history, based on all the data they have about you, your spending patterns. They can predict that, okay, this person, if I give him a loan, it will pay back. They use machine learning to do that. They train models on large amount of your data to do that. So that's a type of machine learning. But deep learning is not too good at those kind of tasks. It's mostly good at tasks that relates to image classification, things that we just did, video segmentation, image recognition, natural language processing. Is good at those type of tasks because it's an easier way to actually train models. So that's deep learning. So anytime you hear that deep learning ML, deep learning is a subset of machine learning, and machine learning is like inside artificial intelligence. So next slide. So deep learning excels at many cognitive tasks because it is easier to train and maintain than traditional machine learning models. So you can see in traditional machine learning models, you have an input data, for instance. You as the engineer, you still need to do some manual feature extraction. You still need to like help the machine learning model before it can give you correct output. But deep learning takes both the feature extraction and the classification tasks together. So you're just giving the images or anything that you are doing, examples. It does both parts together. So that's the deep in that. So it's very, very effective at most of these tasks, and there are like a bunch of reasons for that. So now I'll be talking about all these technologies, deep learning, ML, this and this, blah, blah, blah. So if you are not somebody that likes to code, or if you are not somebody that wants to really go into ML as a whole, there are tools that are available that you can plug and use, plug and play. You can just connect to their API, or you can just embed into your application and you use. But if you like to code, you can come and join us and do some, Python, TensorFlow, stuff like that. So I'm going to show you some code and no-code tools for ML. So for no-code tools, these are things that you can, drag and drop, train some models. Once you get the model, you can embed it in your application. If it's a web app, you can put it there. If it's a mobile app, you can put it there, and things like that. In less than 20 minutes or so, you should be done with most of your tasks, unless you are doing something very complicated. Okay, like there was a talk I gave last week where I basically trained a model to detect bad posture from good posture. So imagine if I'm sitting in front of my computer and I'm slouching like this. The model will quickly recognize that live from my cam and tell me that that's a bad posture. So I have to sit upright. I trained that in less than 30 minutes. Less than 10 minutes. If there was time, I would have shown you. I used this teachable machine to do that. So I just gave in a bunch of examples where I was slouching and I gave it a label, bad posture. And I did good posture, I gave it a label. I just clicked train. It trained those things, gave me a model. That model, I can export it to TensorFlow.js, which is JavaScript for web people. You can just copy it, put it in your file directory, and you can call it and use it. Or you can export it to Python, anything that you want to do with it. So with that, I just copied that and put it in my React project, and I just passed in the live feed from the video cam. In HTML, you can get a live feed. There's a video element. I just passed that to the model. Instantly, I'm getting predictions in less than 15 minutes. So you can do something as smart as that with these no-code tools. So imagine, how can you take that further? Maybe you can put it into an extension, a Chrome extension that just sits in your browser. Anytime you are working and you slouch, it just shouts at you. You can connect it to a sound. The browser has this sound API that you can connect to. You just shout at you that bad posture, okay? So you sit upright. Very easy to do. And you are a web dev. You are doing something very cool with ML already. So you don't need to learn how to code, but if you want to go further, then you can do that. So there's Teachable Machine. Just go to Teachable Machine. I think teachablemachine.google.com. There's the link. I will show you guys a link later. There is Google AutoML. This one is more complicated. It has more features. You can even do video transcription. Imagine you have hours of videos that you want to extract data from. Maybe you want to know when people were clapping in the video. You want to know when something was happening in the video. You can pass those bunch of images to Google. There's this video API, and it automatically do that for you. So you don't need to learn how to code to do it. So there's also this. There is Amazon SageMaker. There's IBM Watson. If you are doing this relating to chatbots, natural language processing, and the rest, there's also Dialogflow. So these are all nice tools. There's BigML. Advantages, I've been seeing the advantages since. You don't need to be an expert. You can easily deploy to REST endpoint. It's codeless, less data preparation, quick prototype, and they were developed by industry experts. So they were developed by people like us who are lazy and want to, automate most of these things instead of doing it over and over again. That's why most developers build libraries, because instead of doing something over and over again, just take an existing tool and just use it. Disadvantage, you take what you get. So depending on the limitation of the platform, that's where your solution stops. Not easily transferable, can be more expensive sometimes, security and privacy. I think I should rush this now. Please, next slide. So if you want to write code, these are a bunch of tools. TensorFlow, these are like libraries. basically the way you call your libraries in your web application, the way you do npm install store so and so, and you use it. Basically, that's how you do for all these. These are some amazing libraries that you can use to build machine learning models and stuff like that. Advantages: customer niche problem can be easily solved. If you are doing cutting edge research in the field, it's good for you to write code. Next slide. Disadvantage: you must be an ML expert. Managing end-to-end lifecycle is tedious, takes longer to get to production, and stuff like that. So next slide. Now, for web developers, there are some amazing tools out there that you can use. So you can easily use them in your project. There's TensorFlow.js, which is very popular. I'm going to show you some demos that were built using TensorFlow.js, all in the browser. There is P5.js, works with TensorFlow.js. There's Danfo.js. This is the one I'm working on. So this is it. Okay, so please check it out. There is Teachable Machine, which I just showed you. So next slide. Demo. Okay, some bunch of demos. Next slide. So this is an in-space. This is using, this is running in the browser. The model is also running in the browser. It was built with TensorFlow.js. So basically, they are using real-time toxicity classification. So if there is a toxic message, in real time, once you send it, it automatically flags it, and it does not send. So you can see this is happening in real time. So imagine having this in your chat application. So you can see it's not going to send because the message is toxic. So it was trained using TensorFlow.js. So this is Project Shua, and it uses pose. So basically, your pose, you can use that to, you can track your pose. So you can see at different points, track your pose, and you can use that to do cool stuff. For example, you can use that to do sign language. Thank you. So you can use that to do sign language detection. So maybe somebody is signing, and you can automatically transcribe their signs to words. So you can use that for that. You can use it to play games, to control stuff in your browser. So imagine you are doing like this, and your browser is moving. It's very easy to do with TensorFlow.js. The models are ever available. You can just plug and use them. Imagine in front of my browser, I don't need to press down. I'm just moving. Because it's tracking my hand movement, I can use that to control my browser. Maybe I can do like this. So you can do cool stuff with TensorFlow.js. It's very, very nice. Next demo. This one is using pose. It's called the pose animator. It's a pose model. It can track your movement. So it's using that movement to animate an image. This is an SVG image. So what's happened is that it's tracking the person's movement and it's projecting it onto the image. So you can turn an image, a static image, to a live animation based on it's tracking the pose of the person. So depending on the points on the person's face or on the person's hand, if that part moves, it also moves the image. So these are like cool stuff that you can build. TensorFlow.js as well. There's also this one that uses pose estimator to also track exercise. So as you are, can help you to count, can help you to check your balance. These are like amazing stuff. And all these are all running in the browser. So you can just go to this link. There are lots of demos there, lots of cool stuff. There's one that plays piano. There's one that controls the game with just head movement. You can do like this, and the game is moving upwards. So go to this place and you see more inspiring examples. I think next slide, that should be the last one. So conclusion. Conclusion is that you can do cool stuff without writing code. And if you still want to write code, you can still do those cool stuff. So as web developers, you are not limited. You must not be an ML expert. You must not be a deep learning expert. You can use already existing tools. Please go to the next slide. So you can see lots of resources for you to get started, for you to do different stuff. And I can't wait to see what you build. So please try out TensorFlow.js, try out Danfo.js, try out AutoML and the rest, and just build amazing stuff. Thank you very much. So, okay, I think I have small time for questions.
So can we use those libraries? Can we embed them into using embedded systems like Arduino and Raspberry Pi?
Okay, yes, you can. So there is TensorFlow for embedded devices. So you can deploy them to your Raspberry, Arduino. mobile, on edge, anything on edge, you can do that. So TensorFlow also have that as well. So if you go to tensorflow.com or tensorflow.org, there's a particular library that was built for that. So there's one for JavaScript, there's one for Python, there's also the one for embedded device like Raspberry Pi.
Okay, so my question is, there was the slide that said one benefit of using ML in the web is security and privacy. So if you don't use web, how do you ensure security and privacy?
So yes, for security and privacy, it's tricky because most models that you use will require you to send your data to a server. So for instance, if I'm doing image classification and I upload an image to a web browser, for instance, I want to classify the image, just an example. It requires you to send that image to a server, to somebody's server. So you don't know if the person will save the image or will delete the image after, so you are not sure of privacy, okay? But when you are using the web for ML, things like TensorFlow.js, everything happens in your browser. So the model is sitting in your browser. The model is not in a server. So if you want to classify image in real time in your browser, your data will not leave your browser. So everything is there. So that's one of the biggest selling points for doing some ML in JavaScript. Although the field is not matured, Python is still like the leading tool or the leading library for ML. But one of the biggest advantages for doing ML in JavaScript is that privacy and security. Everything happens on your device. It's not going anywhere. So that's like the selling points. Okay, I have a question. Okay, yeah. So I think that's one of like the major reason why people are always against using JavaScript for ML. They are always talking about performance in the web. So the thing is that people like us that like JavaScript a lot. So people have been working on tools that pushes the boundary of doing computations like that in the browser. So if you notice now, there's Web GPU. Don't know if you've heard of Web GPU. Yeah. So basically, the reason why tools like Figma works in the browser, whereby you can do some crazy stuff in the browser. If you notice, some people are even porting Photoshop, some video editing apps to run just in the browser. The reason why that is possible is because of tools like Web GPU. So it gives you a GPU on your browser that makes computations fast. So things that have to do with 3D animation, video editing, they involve lots of computations. Gaming, for instance, they involve lots of matrix computations. So they use the GPU a lot. So now the GPU is available in the browser. There's a Web GPU, although it's still a little bit limited, but people are pushing the boundaries of these technologies. That's why these tools are available. TensorFlow.js, for instance, uses the Web GPU. So it's in terms of speed, it's almost the same with the native Python environment or the native Python experience. So in terms of performance, it's, how will I put it? It's still not exactly the same as Python, but we are getting there.
So I know that I've read in articles saying that TensorFlow, like with JavaScript, you can't really do as many things as you would do with Python. So like what exactly are the limitations of using JavaScript, apart from obviously the performance issue that has already been brought up? Like can you virtually do everything that can be done in machine learning with a library like TensorFlow?
Okay, yeah, so the answer is yes. You know, JavaScript runs server-side and also browser-side, Node.js. So basically, the TensorFlow Node version is exactly the same API as the TensorFlow Python version. It's even faster. Yeah, they did a benchmark test officially because Node has this JIT, just-in-time compiler, so it's faster than Python, slightly. So, but for the TensorFlow browser version, it's a little bit slower than that. And there are some computations that are not available yet. But I think majority of the tensor operations are available. So it's just maybe the advanced ones that are still missing. But like I said, constant work is happening in the space, and these things will be available soon, very soon. Any other question? None? Thank you very much.